So we'll move on to our next presenters, Sarah and Fritz, and they're talking about map projections, which is something that Lynn was very passionate about.
While I wait for the slides to show up, just a kind of a quick list. I met him when I was a master's student a few years ago, and it was at a commission on map projections workshop, I think, and he has just played such a huge role in my life and my career since that point. And I think I probably speak for Fritz as well. Hopefully I'm not like making up words for you. Like I just think he's really had such an impact on both of our careers. And it turned out that about a week before he passed, we discovered that he had written a review of the map projection book that we wrote. And so I sent an email to Fritz and said, did you know about this? I don't have access to it. If it's good, send it to me. If it's not, don't. So I got an email back pretty quickly with the review. And we had been communicating with Lynn after that point. And it turned out he really liked our book, and we were talking about workshops that he was planning to give on map projections and the role that the book might play in there. I don't know, unless people can't hear me well, I'll just kind of try and hover. The other mic. Okay, I'll just use the other mic. And we were talking about all these workshops he was going to teach, and it was just so exciting until the emails stopped and we found out why. And it was just really soul crushing because Lynn was such a wonderful person. But on a happier note, we're going to talk about map projections, and I could imagine that he would be sitting in the audience and probably nodding and potentially looking a little intimidating because he kind of looked a little intimidating. So Fritz and I, we've done some work. We're looking at some of the research literature in cognition and perception of map projections, and we're going to talk about that. So the first thing is generally why. Well, it's because map projections play such a huge role in everything we do, from the analysis that we do to how we communicate about the world to other people. And the distortions in map projections, whether it's area, distances, directions, they are going to change the way that people perceive what's on our map, and they're going to change the patterns that people see. And they're also going to change the way that we think about space in a deeper way. So all of the cognitive processes that we have in terms of how we make sense of the world. So to explore this, Fritz and I have been exploring a lot of the research literature on how people have studied cognitive and perceptual processes related to map projections. And we're going to talk about a subset of the interesting things that we've been finding as we go through 4 or 5 decades worth of research in this area. So one of the things that really has jumped out at me is that there is this huge impact of just the way that we ask the question. And it has some really funny impacts. One real simple way of looking at it, there's been a lot of work looking at sketch maps of the world, and how you ask people to draw that sketch, I think, makes a big difference in terms of what you get with the shape of the world, what you get in terms of how locations are distorted or not. For instance, with these 2 examples, one was draw the world. You get a very simple, here are some continents, and you can take some measurements of that and do some analysis. But what if you ask somebody to draw all of the countries that you can think of? I mean, there are lots of ways of approaching that. I can draw the outlines and start filling in and breaking things up, which has some impact in terms of the size that we end up, because I don't know if you think about trying to draw all of the US states. I do this periodically just to kind of mess with my mind. And things get squished really fast because I'm bad at this. But if I can just draw the outline, it gives a different result. So the way we get people to externalize information makes a really big difference in what we see and what we can measure at the end. The way we ask the questions also often don't make sense. So this is from a paper that Dan Montello and I published earlier this year. And one of the questions we had was looking at how people's idea of directions was sort of warped, because we have this assumption that people are really probably thinking about direction in a plainer sense. But how do you ask somebody about directions without saying, hey, think about the map as a flat thing and draw a line that's probably going to be wrong, but it's a direction? Because what we really wanted to do was get at the cognitive process. So we came up with this question: estimate spherical direction as a jet would fly. And so I talked about this with one of my colleagues, this guy Dan Strebe, who's a big map projection nerd. And our conclusion in the conversation was, this is a stupid question and it makes no sense. But how do you ask someone to externalize spherical information on a piece of paper without totally misleading them or getting them to give you the thing that you want them to give you because you just asked them a totally leading question? It's a hard, weird problem. And I thought I'd skewer my own work. Or what if you're asking somebody to plot the location of cities, and I want to know, what does your mental map look like? Where are these things in space? Well, what happens if I give you a nice rectangular grid? What happens if I give you something that is not a rectangular grid? How many people think about location in terms of lines of latitude and longitude? Pretty much no one. And so the shape of the grid may actually skew the way that we can get information about what people think and how their mental model is put together. And we haven't really seen a whole lot of exploration of what is the impact of that type of stimulus. We've got some problems with how we analyze, because map projections are kind of hard and people screw them up all the time, including the people who are trying to do analysis on them. So this is one of the papers that I really love, and I'll admit, one of the reasons I love it is because they drew their correct solutions to shortest paths between locations, and they don't actually match up with what I get when I create a geodesic. And so I'm kind of curious about how they did their analysis to compare how accurate people were in drawing their paths when they're comparing them to something which I'm not sure is actually right. Or when we're doing visual analysis. When we're analyzing data, the numeric analysis is really important, but the visual analysis of our results is also really important. And one of the things that really jumped out at me at a paper where they were looking at people estimating locations for cities, there was this great graphic for the mean estimate for each city computed across participants. And the error bars are the standard errors for the number of degrees. And you can't actually compare a degree of latitude and compare a degree of longitude on this. And so it makes me really wonder, like, what are we getting visually when we look at the data? Because the whole spherical to planar translation is just hard for a lot of people. And I think we're doing a lot of analyses visually that are probably incorrect, and a lot of analyses quantitatively that are probably incorrect. And we need to be cautious about that. There's also this really cool problem that, there are be dragons at the edge. And if I had a nickel for every time someone told me at work, well, that line's going the wrong way, can you guys fix it? And I go through this whole process of, it's actually the shortest path, and no, I can't fix it. I mean, I can tell you how to put an intermediate point, and then your line isn't really the shortest path anymore, but that's cool. It turns out this is actually just a really hard problem for people, because even when you know that something is true in a spherical world, when you see it on a flat map, you often totally forget that. And it makes it so that it's really this weird mind-bending space to both do research, but also to be in the world where you're trying to help people see and understand their data correctly, because people know that something is wrong, but they also totally throw that out the window when they see a map, because this is a great, the Eggenhofer and Mark paper on naive geography, maps are more real than reality. It is so true with almost everything we do with map projections. And now I'm going to hand things over to Fritz.
All right, so part of the process is to teach and learn about map projections, and that process necessarily involves rules, right? Some of these rules are pretty authoritarian. Choropleth maps require equal area projections, large-scale topographic maps require conformal projections, yet some of these rules are a little more bendable, right? What do equidistant projections allow for? So some of these rules are challenging. So we have an example here, the line should be curved. Well, it's true in some cases, but not in all. And when does that rule get bent or broken in some cases? The other transferability here is the issue of Antarctica and Greenland, the famous comparison. Antarctica and Greenland are too big. Well, that's true in some cases, but not in others. So when do we allow the knowledge transfer to understand when that rule can be broken or in some cases bent just a little bit? There's another process that we go through is to teach about distortion. And on the left-hand side there, we see the issue of the familiar developable surface as a conceptual aid to help understand the projection process. Yet, there are some that would argue that the developable surface is not really possible because not all map projection classes follow a developable surface. And part of the developable surface idea also involves this idea of a light shadow point of projection. Research has shown that the ability to understand shadows is rather challenging for many people, and therefore it may not be the best way to conceptually model what the projection process actually involves. And then on the far right, we have the visual detective from Judy Olson that would outline more rules. For example, if your parallel spacing decreases from the equator to the poles, then that's an equal area candidate projection. If that spacing increases, then it's more of a conformal projection. Yet those rules don't often hold up in every case. So again, bending those rules is often a requisite for completely understanding the process. Distortion. If we accept the fact that all projections distort, some are part of the Earth's surface, then we're left with the process of how do we visualize that distortion. Cartographers know a lot about proportional circles, data classification, choropleth, color schemes, and so forth. Yet there has been no research conducted on how distortion symbolization methods are understood by the end user. We see various attempts to show distortion through symbols. One, of course, being just look at the continent or the landmass and compare that visually to the globe. TISO's indicatrices are often reported. They're not heavily found in textbooks. There's been some concern that the TISO circle itself or the indicatrix is more an expression of where the distortion is. If it's inside the circle, then it must be distorted. But obviously, these refer to infinitesimally small points. We have the isocals, various shapes and so forth that appear on the projection, and then the gradation of the color. Darker means more distortion. And then, of course, moving to the next phase, how do you select a projection? There have been several attempts to codify a projection selection process. And I'm referring to most of these as being a top-down approach in the sense that the experts, those of us that know something about projections, have tried to develop these selection guidelines and attempt to help the end user come away with a reasonable selection of a projection for an intended map purpose. Most of these, unfortunately, remain folded in obscure journals that are largely inaccessible or contain a myriad of various complicated terminologies that may not be immediately intuitive to the end user. Perhaps we could reconsider this as a more bottom-up approach. The one quote here, no single existing solution fully incorporates both key selection elements of a map purpose and the geographic footprint characteristics, whilst also including methods for distortion reduction and visualization. So the attempt by these authors was to marry the geographic footprint, as they call it, the area of focus, with the map purpose. But they stopped short of actually incorporating that map purpose into their selection guideline, and they instead substituted distortion measures for that map purpose. So some of the questions that we can ask here is, who actually is the intended audience for the selection guidelines? Does one size fit all? If we have this big selection guideline, does it work for everybody? Well, I think not. How helpful are the guidelines? We've never done studies to understand if the selection guidelines are used, which ones, or if they're helpful in helping the selection of an appropriate guideline. Do the end users know what a projection property is required? Or if they do they understand the terminology? Conformal is often misconstrued as being correct shape. That may be true, but the understanding the nuance of what that shape actually means is somewhat mystifying to some. And then, of course, going back, do people actually use the existing guidelines? We don't know yet. Also, with the implementation issue, if the accessibility of these guidelines is difficult, challenging, they'll probably be relatively obscure. If they're included in a digital environment, perhaps that's a more accessible platform. So what are the big takeaways? Distortion in map projections make both research and analysis challenging. There needs to be a bit more research done in that respect. There's a notable disconnect between what we know about projections and how we perceive data analysis in projected space. So trying to understand the disparate, the disconnect there is another challenge for our research agenda. More research is needed, obviously, on what and how to teach about map projections. And then education outreach beyond formal school settings, because we realize that there are people that are not necessarily through a formal cartography or GIS background that are making these decisions and need assistance in those decisions. And then map projection selection guidelines are potentially useful, but more thought needs to focus on the end user requirements and what they understand in terms of what they need for an appropriate map projection. Thank you.
No questions? I can ask one. So I'm just asking about students. When we teach map projections, right? Do you know what is the best point in a GIS class to introduce map projections? I've tried in different weeks and I've not succeeded. Like no matter when I teach map projections, it doesn't stick and I have to try it twice and thrice in the next classes. Does anybody know what is a good, at what point of, let's say they're coming in blank with geospatial, at what point do they know enough to like talk about it?
I don't know either. That's part of the problem, right? We don't know. And until we conduct research to figure out what is the best time or what is the requisite knowledge, I don't have the answer.
Okay.
So that's part of the problem. Not only is it when to teach, but what to teach.
Yeah.
Right.
I mean, like I've tried it, split it up, maybe do a little intro first, then they know a little, then they come back. But it doesn't seem they come to my advanced class and they don't remember.
And then the same questions can also be raised with datums.
Yes.
Which are critically important for GIS work.
Absolutely.
And that's a whole nother, it's gone over my head.
And I want to remind people, Nick.
Cool, thank you for the presentation. It's a kind of similar question, really. There's a lot of stuff that we don't know that you've highlighted really well. Is there any advice or any kind of key points that you could pull out that would be useful for us teaching projections and coordinate systems? And happy for anybody else to contribute as well. I'll put my 2 pence in. When I'm teaching in a relatively short course environment, I link it with coordinate systems as well and talk about both as one. And it seems to stick a bit, but then I never go into more detail later because I'm not going into that depth with the students. So very happy to hear anybody else's comments as well.
Yeah, I'll just kind of talk to that a little bit, because it was sort of something that came up in the Commission on Map Projections workshop before the meeting as well. I feel like it's the sort of thing where, for me, what really worked was teaching through bad examples. Why does it matter if you do X with a projection? Why does it matter if you do something else with it? And that was something that we had thrown around as an idea of potentially starting to make a little library of vignettes, these small examples of what happens if you do your interpolation on X, Y, or Z projection. What happens if you use an equal area and you should have used an equidistant. What does it really mean when you use an equidistant projection? What happens when you measure from any arbitrary point to any arbitrary point? I think that there are a number of examples that help bring home to students what some of the issues are. The problem is also just going to be this cognitive issue that we've seen so much in the literature and just through anecdotal evidence, that sometimes people know the problem and then just out the window and do the work. Like one of the things I found in my dissertation was I would show people a Web Mercator wall map and say, can you estimate the actual land area, not the projected area? I was very clear, not the projected area. People would be like, oh yeah, that's a Mercator projection. Greenland, Antarctica, ooh. And then they would almost perfectly estimate the area as it was shown on the Mercator projection, because even though they would look without any prompting express, I know the issue with this map projection, it's just in one eye and out the other. And that's something I think we're always going to fight. But at least if you have those examples, it makes it more likely to think, oh, let me be consciously aware of the fact that there might be something that comes up, but it'll bite you every time.
I'll just add one real quick thing here too, is in your examples for your assignments and whatnot, have a projection element in all of them. Vary the geographic region that you're mapping as the lesson, vary the scale, and make the projection a constant element of the design decision or the cartometric decision, or whatever the lesson happens to be. The projection choice should be an important element in all of those. Yeah.
I have another question. I was intrigued by Sarah's example of the dragon map and how we geographers think intuitively about the broken lines, but for the users, it might be feel confused about the line was broken. My question is, it seems to me that there is a transition or involving a ways of the people perception maps, because previously only the professional guys are making maps, but now everyone can make map and use maps. So under this big context, I try to know your thoughts about, in terms of percepting the maps, should we somehow improving or rewire the way we designing the map projections or use map projections? Because the people who using map and the people who design map are enlarging, right? Comparing 10 or 20 years ago.
No, that's a great question. I think that gets back to my point that we need to do a bit more research on what the people who are using the map know about projections or don't know, and what are their requirements. What do they think they know? What do they think they need to use the map for? And then conversely, the map maker, who may not be formally schooled, or even if they are formally schooled in cartography, what do they perceive as being important for the map end user? What are the requirements they think are important? I think there's probably a disconnect between those two groups in some levels, and largely with map projections. So if we can figure out the ends of those two continuum, I think we'll be in a better place. So that's kind of what we're arguing here. But thanks for that question.
Yeah, I have basically a comment and echo. On the cognitive part, when I was doing my research on different map projections, I had the two big groups of users. One was US users and one were Indian users. There was no significant result, but I did saw that Indian were more inclined to the projections that are more round versus Americans were more like interested into more square and flat. So there was like a big difference that actually showed like it was significant, like it was enough that I was able to see, but I could not actually prove the strong significance in between them. So I think there is like a little bit there, the cognitive part. And the other thing that I would just echo what Fritz, you concluded at the end, too many times we focus on students and how to teach students, but I do believe we have to teach a lot of geo-professionals today about the coordinate systems, map projections, datums. There's a huge, huge lack of knowledge in the professionals, not just students.
Thanks, Boyan.
Yes, we see this. I work, Boyan and I work together. We see this all the time in that it's kind of an afterthought. Like people just want to, they focus more on the color and a great presentation, and the actual underlying coordinate system is, I don't want to deal with that. It's a little bit too hard. I think it's more exposure and more of an emphasis. And as far as teaching goes, when I had my cartography courses as an undergrad, it was one lecture on map projections, and it was kind of the, light inside the globe thing and all of that. I think when you go more in depth and there's an actual course on map projections, you get in more into the meat of the matter, but there's a perception that it's hard and people don't want to go to that depth. The cartography in a lot of cases has moved towards, it's more of the presentation and the artistic expression and not about the underlying mathematics, but that is the core if you want to have accurate locational information. So I think it's just a matter of, I don't think you're going to fit it into like 2 lectures in a cartography course. I learned it when I actually took a full course on map projections, and then you get deep and then you start to get the understanding. You're not going to teach nuclear physics in 2 lectures. That's my opinion.
I think the lack of to address your point, David, the lack of specific courses on coordinate systems, map projections, datums. Maybe I should leave.
There is David also online, so he wants to ask.
Oh, okay. No, just to support your response there. I think, and I'm biased, but I think there needs some more dedicated courses on map projections, datums, and coordinate systems than what there are. I mean, personally, Mark Kumler and I mean, those are the only people I know that teach a separate course on projections, at least in the U.S.
Yeah, I think I was fortunate to have one of those courses from Waldo Tobler, and actually it's why I do what I do here for a career. I think it's important that there's more of an emphasis on it. It, in my opinion, in American universities, it is just kind of passed over and not emphasized.
We have a question online. Go ahead, David.
Right, so very quickly, hi Fritz, hi Sarah, this is David. I'm sorry I wasn't able to be there in person, but I was at least able to enjoy your presentation online. I agree very much with the previous comments. I think this is the least well understood aspect of geospatial science of them all at all levels. But some of us do have to teach classes in which map projections and reference frames are just one chapter in a longer story. So I wanted to, with that in mind, I wanted to ask the two of you, what do you feel is the single most important misperception, maybe from a cognitive point of view, or misunderstanding about this area that educators really ought to focus on and not overlook?
I'm going to let Sarah respond to this.
Yeah, the one thing that I really hate is the idea that latitude and longitude are just latitude and longitude, because it turns out it kind of matters what your datum is. I've seen so many problems of, but I had latitude and longitude in an Excel file. Why are they in the wrong place? What do you know about them? Their latitude and longitude, they're right, aren't they? That drives me crazy. And false decimal places of precision, but that's a different story.
All right, thank you very